Section 4.5 talks about exponential and logarithmic equations. So the directions here say, let's solve each equation, and we're going to give irrational solutions as decimal correct to the nearest thousands. So in case you're wondering, or maybe you forgot, thousands is going to be in 3 decimal places, okay? Oops, places. There we go. Okay, so I'm looking at the problem that we have. I'm going to write it down over here on the side. And it says 3 to the power x, is equal to 7. So if I were to sort of start guessing, like what's 3 to the first? Oh, well, that's 3. That's too small. 3 squared, oh, that's 9. That's too big, because we're trying to get to the number 7, right? So we know our answer is going to be somewhere between 1 and 2, and probably closer to 2, a little bit less than 2, but closer to 2 than it is to 1. So we got to figure out, how do I solve an equation when I have my variable as the exponent? And I can't solve it like we did some of the other ones earlier in chapter 4. So the way we do this here is we're going to use one of the properties of logarithms. So one of the properties of logarithms says the log base a of x to the power r was the same thing as r of times the log base a of x. So in essence, what we did is when we had this exponent, that exponent would come down to the front. So the reason why I'm going to do that, even though I don't see any logarithms in my problems, is we're going to take the logarithm on both sides. Okay, so I'm using the common logarithm because I'm not writing the base. So again, that means that the base is going to be the number 10. Okay, now this exponent is going to move down to the front. So I'm going to have x times the log of 3 is equal to the log of 7. So now I can just divide both sides by the log of 3, okay? Now guys, I want to mention something here. When I have this log of 7 divided by the log of 3, I cannot cancel out the words log, okay? It's a function. It's an operation, okay? So what I need to do here, I'm just going to use my calculator. Let me get it going. Let me move it to this side. Let's turn it on. Let's clear it out. So I'm going to type in exactly what I wrote down. The log of 7, close off your parentheses, divided by the log of 3, close off your parentheses, hit equals. We're going to go to 3 decimal places. So again, my answer, me approximated, is going to be 1.771. Okay, so approximately 1.771, and we are done. Okay, I'm going to do the exact same thing in this next problem here. Okay, so every exponential equation, I'm going to solve it exactly like the way we just did right now. Now, I wanted to mention something. Let me grab my calculator again. Remember, my calculator can do 2 types of logarithms. It can either do the log, or it can do the ln. Which one do you use? That's entirely up to you, okay? So, let's do the same thing here. This time, I'm just going to use the ln, okay? Why? Just because we can. Because my calculator is capable of doing either one, okay? If you want to stick with a log, just because it's easier for you, if you feel it's easier that way, hey, stick with a log. It's not a big deal, okay? Now, I'm going to bring this x down here. So this is going to be x times the natural log of 1/2 is equal to the natural log of 5, okay? Now, we're going to divide both sides by the natural log of 1/2. Okay, so these here are going to cancel. So we're going to have x is equal to the ln of 5 divided by the ln of 1/2, and we're going to approximate it now. So again, I'm using the ln, so I'm going to hit ln of 5 divided by ln of 1/2, so 1/2. Close off those parentheses. Okay, don't forget to close off your parentheses, y'all. Hit equals, and we're coming up with a negative 2.322. Negative 2.322, because again, we're still going to 3 decimal places for all these problems. Okay. Alrighty, I'm going to keep moseying on here. Yes, I said mosey. All right, so which one do you want to use? Oh, let's go with log. Let's just go back to log. So the log of 0.8 to the power x is equal to the log of 4. Again, that x is going to come down to the front. the log of 0.8, okay, I'm putting it in parentheses just because that's how our calculators write them, is equal to the log of 4. So let me divide by the log of 0.8 on both sides. Okay. Remember, those cancel out. So x is equal to the log of 4 divided by the log of 0.8. And we're going to approximate it now. So the log of 4, again, don't forget to close out those parentheses. It's real important. Divided by the log of 0.8. Okay, close off my parentheses again. And to 3 decimal places, negative 6.213. So negative 6.213. And again, there's my answer. Okay. So here's my next problem. First thing I want you to notice is that all of them have the base of e. This is really important. Okay. So remember, when I want you, before I kind of do this problem here, I'm going to kind of scooch over to the side and show you something else, okay? Because I want us to think about this for a second. Suppose I had y to the 5th times y to the 7th. If you remember, when our bases are the same, when these are the same and we're multiplying, what do we do with the exponents? We add them in Eve, right? We add them up. So the reason why I want to think about that is when I come back to the problem that I have, which is right there, I want you to notice we have the same base. What am I going to do with my exponents? We're going to add them together. Negative 3x plus 7 plus a negative 2x. Okay, I'll worry about this piece in a second. So if we combine our like terms, 3x minus 2x is an x minus 7. So we have here, we have e. Let me get rid of this little equal sign here. I'll put a little arrow. So here we have e to the power x minus 7 is equal to 4e. Okay. Now, since I am dealing with e, I'm going to go ahead and take the natural logarithm on both sides. Okay. So when we take the natural logarithm and e are going to cancel each other out. So what's going to happen? This x minus 7 is going to drop down. Okay. Now, what else do we have over here? So there's another rule that says when you're multiplying two things on the inside, you can separate them by adding. This is going to be the natural log of 4 plus the natural log of e. Okay. So let me just move over a little bit more to my right. Okay. So now we have x minus 7 is equal to, I don't know what the natural log of 4 is, but the natural log of e, remember the natural log and the e cancel out. What was the power here? It was a 1. So I have natural log 4 plus 1. Remember, what am I solving for? I'm trying to solve for x. So all I need to do now is add 7 to both sides. And I'm coming up with x equals the natural log of 4 plus 8. And there's my answer. Okay? And it doesn't look like a typical answer that we would get, but in this case, this is what we have, okay? So let me bring my stuff back here. And again, the directions say solve, give the exact answer. So we're going to do that. So I want you to think about, we did this a long time ago, somewhere back in chapter 1, like in week 4. And we solved equations that were quadratic in nature. And we would say, let's let u be equal to the middle part. So u is going to be e to the x. So that would tell me that u squared would be e to the 2x. Okay. So now I'm going to rewrite this problem using the letters u. So e to the 2x, that's the same thing as u squared. Minus 6 times e to the x. Well, e to the x is the same thing as u. Okay. Plus 8 equals 0. Now, we solved problems like this before. We can factor this one. And notice, since the number in front of the u squared is a 1, my first step is what's 1 times 8? I know that's 8. I'm looking for two numbers that multiply to 8 but are going to add up to a negative 6. What about a minus 2 and a minus 4? And then we can just do this business, okay, because it's a shortcut. And then we're going to set each part equal to 0. So everything we learned back in chapter 1, we're using it again. So here u is equal to 2, and here u is equal to 4, but we haven't solved for x. And my original problem is asking me to solve for x. But remember what u is equal to. U is equal to e to the x, okay? So right here I'm going to say e to the x is equal to 2, and e to the x is equal to 4. Since we're dealing with since we're dealing with the base of e, we're going to take the ln on both sides, okay? Now, remember, the natural log and the e cancel each other out. What drops down? X. So x is equal to the natural log of 2. The natural log and the e cancel each other out. And x is equal to the natural log of 4. Alrighty, let me scooch down. Okay, so now those were exponential equations. These here are logarithmic equations, okay? So we're going to solve for each of these logarithmic equations, all right? The objective is we're trying to solve for x, right? We're trying to get the variable part by itself. So the first thing I want you to notice here is let's go ahead and divide both sides by 5. So now we have the natural log of x is equal to 2. I want to remind ourselves, what does the natural log of x mean? The natural log of x is the log base e of x is equal to 2, okay? So my next step here is we are going to, what we're trying to do is we're saying that this number raised to that power is going to give me this answer right here. So if I think about let me just kind of move this over to the side a little bit here, guys. Here we go. If I think about my definition of a logarithm, we said that the log base a of x is equal to y is the same thing as a to the power of y is equal to x. So notice what we have here. So when we have it in logarithmic form, the way we convert it to exponential form is we're going to say my base number raised to that power is going to be equal to this guy right here. That's exactly what we have right there. So e squared is equal to x. So when I come back here, that's just what my answer happens to be. Let me move this down a little bit. Here we go. So there's my answer. X is equal to e squared. Okay. So again, I'm going to think of the same thing here. First thing I'm going to do, I'm going to write it like this. The log base e of 4x is 1.5. So remember, what we're saying is e raised to this power will give me that answer right there. So 4x is equal to e to the power 1.5. How do I solve for x? All we have to do now is divide both sides by 4. And here's my answer. So notice how it's asking me for exact form. This is what we're looking for. This is exact form. Decimals are not going to work. If it tells me to give it an exact form, that's exactly what it is we're looking for, okay? So let me scroll down. We got a couple more to do. First thing I'm going to notice here, I don't see the base. So remember what the base is here. The base is 10. So we're going to say 10 to this power is equal to this, is equal to what we have in the inside. So 2 minus x is equal to 10 to the power of 0.5. Okay? So now, what do we need to do? We need to solve for x. So first thing we're going to do, minus 2 minus 2. Okay? So negative x equals 10 to the power of 0.5 minus 2. And then, because I have this negative 1 here, let's just multiply everything by negative 1. Multiply everything here by negative 1. Those are going to cancel. So if I multiply it, negative 1 times negative 2 is a positive 2. Negative 1 times that is a negative 10 to the power of 0.5. Guys, I want to mention something here, so I'm going to write it like this. The answer may also be written like this, 10 minus... Remember what 0.5 is. Isn't 0.5 the same thing as 1/2? And isn't 1/2 the same thing as the square root? So those would be, that right there would be my answer, okay? Alrighty. Let's see if we can do the same thing here. So notice, in this problem, we already have our base. Our base is 6. Okay, so this is telling me that 2x plus 4 is equal to 6 squared. So 2x plus 4 is equal to 36. So now when I minus 4 on both sides, we end up with 2x is equal to 32. We can divide both sides by 2, and x is equal to 16. Okay. So the next problem we have here, again, first thing I want you to notice is there is no base number written. So the base number, again, is understood to be 10. If you remember what we said before, when we're adding two separate logarithms, what this means is that we have the log of x times x plus 15 is equal to 2. So I'm going to go ahead and distribute that. That's going to be the log of x squared plus 15x is equal to 2. Remember, my base number here is 10. So what is this telling me? This is telling me that x squared plus 15x is equal to 10 squared. 10 squared is 100. When I move this 100 over, it becomes a negative 100. And let's see if we can't go ahead and factor this guy out. So let me write it here where I have a little bit more room. X squared plus 15x minus 100 equals 0. So remember, my first step, 1 times negative 100 is negative 100. I'm looking for two numbers that multiply to negative 100 but will add up to a 15. What about a 5 and a 20? And let's make that 5 negative. Multiply them, there's our negative 100. Add them up, there's our positive 15. So now we can write x minus 5 and x plus 20 is equal to 100. Okay, let me scooch down a little more. So now we have x minus 5 equals 0. X plus 20 equals 0. So from here, x is equal to 5. From here, x is equal to negative 20. Now, guys, one of the things that I want to mention, and I'm going to see if I can find it in our notes, so give me one quick second. I'm going to pause this, and I'll come right back. Okay, so I came back here to the definition of our logarithm. Let me clean this mess up. This is what we're doing back in 4.3. And I want you to notice, here's my definition, right? Whatever I'm taking the logarithm of, that value of x, let's see, they all have to be positive numbers, okay? So I can't end up with any negative numbers. I can't take the logarithm of a negative number, okay? So when I scroll back down, let's go back to where we was. Let's see, we did that, we did that, we did that, we did that, and here we are. The number that I cannot use is negative 20. So x equals 5 is going to be my only solution for this problem, okay? And that's 4.5.